Okay guys, welcome to this video looking at Year 8 Standard Index Form, and it's from the White Rose Maths website. So White Rose Maths are a fantastic website and resource website for Key Stage 1, Key Stage 2, Key Stage 3, GCSE, and it even has some stuff, I believe, for post 16 maths, so potentially for AS level maths as well. Okay, so please do go ahead actually guys, and if you get a chance in your spare time, please check them out guys. Okay, I'm not endorsed by them, but they are a fantastic company. Okay, and they have fantastic resources. Okay, right guys, so feel free to obviously pause the video, okay, try and attempt all the questions or the ones you can do, and then come back and press play and grab your pen, pencil and notepad, okay, and feel free to make any notes from today's video. We're going to start with question number 1. Fill in the boxes to complete the statements. 10 to the power of something is 10 times 10 times 10. Well, I've got 3 10s there, so it's going to be 10 to the power of 3. So I pronounce that as 10 to the power of 3, or you might hear teachers say 10 cubed, okay, or 10 to the power of 3. Okay, this is my power or exponent. Okay, so this is what I raise it to. Okay, next one, 10 to the power of 5, 10 times 10 times 10 times 10 times 10. So I do that 5 times. Okay, next one, 10 to the power of 3 times 10 squared. Now the laws of indices state that if I have the same base and I'm multiplying, I just add the powers. So 3 plus 2 is 5. Okay, so make a note of that guys. So in general, x to the power of a times x to the power of b is x to the power of a plus b. Okay, provided that you have the same base, you would just add the powers together. Okay, for that. Next one, 10 to the power of 7 times 10 to the power of something equals 10 to the power of 11. Well, working backwards, if I do 11 take away 7, I get 4. So 10 to the power of 7 times 10 to the power of 4, well, I will just add the powers. 7 plus 4 is 11. So that does confirm that my answer is correct. Question number 2, write as ordinary numbers. So ordinary numbers just mean like normal numbers, like the number 1 or 10 or 1,000. Okay, 4 times 10 cubed. Well, 10 cubed is 10 times 10 times 10, which is 1,000. 4 times 1,000 is 4,000. Okay, so 10 cubed means 10 times 10 times 10, which is 1,000. 4 lots of 1,000 is 4,000. Next one, 3 times 10 to the minus 5. Well, the minus 5 here means that I'm going to have a decimal. Okay, so I'm going to have 0.000003. Okay, and I can just check 1 2 3 4 5. Okay, so that does confirm my answer. So a negative index, okay, gives us a decimal answer, and a positive index or a positive exponent gives us a large number. Okay, and this is the whole idea of what standard form is. It's just a mathematical way of writing really big numbers or really small numbers without having to write like 0.00000, okay, etc, or without writing like 4 trillion or 4 billion. Okay, it writes it in like a mathematical form that is easy to understand. Okay, next one, 8.9 times 10 to the 4. So I'm going to have 0.00, okay, 089. Okay, let's just check here. 1 2 3 4. Yep, that confirms my answer is correct. Okay, for that one. Question number 3, complete the statement using the greater than or smaller than. Well, if I look here, okay, the power of 10 is bigger here, so straight away I know that that's going to be bigger than that. Okay, because if the power of 10 is bigger, it doesn't necessarily matter what the start number is. If the power here is bigger, it means I'm going to have more zeros, okay, which means I'm going to have more place values, Whereas here, okay, the number's going to be slightly smaller because it's power of a 6. Power of a 6 would be a million. This would be like 100 million. Okay, so it'd be like, yeah, 120 million. Whereas this would be like 67 million, if that makes sense. Okay, or 100, yeah, or 100, yeah, I think I said that right, actually, 120 million, I think. Okay. Next one, which one has like the bigger power? Well, here we've got to be careful. This has a power of -1. That's bigger than -5. Remember that a negative, the smaller a negative, okay, the bigger the number, if that makes sense here. So like -1 is bigger than -5, -5 is bigger than -9, etc., on your number line. So my answer is going to point in this direction. Question number 4, work out the calculations giving your answer as ordinary numbers. Well, 3 times 6, okay, is 18. So I'm going to have 18 and then I'm going to have 5 zeros after it, okay. Don't worry a lot, guys, about the pronunciation of these numbers, okay? Because although it is actually part of the GCSE specification, okay, as long as you get like the right number of digits here, how you pronounce it, obviously it is actually partially important, but as long as you're happy that a million has 6 zeros and a billion has 9 zeros and a trillion has 12, they are like the main ones that you need to know, okay? If it goes past that, then they'll never ask you what is the name of a number that has 15 zeros, let's say, okay? As long as you are able to write the numbers here in the right way. 6 divided by 3 is 2. 2 times 10 cubed is going to be 2,000. Okay, next one here, I've got to be careful. I've got to use bid maths here. So I've got to work out this bit first and then add 3. Okay, 3 add, and then I believe I'm going to have 700,000. Okay. 1, 2, 3, 4, 5. So I'm going to have 700,000. Okay. And 3, guys. Okay. So put in a comma there. Okay, so put in a comment there if you're interested. Okay, this one, again, using bid maths, I do 3 plus 7 is 10, so what's in the bracket first? 10 times 10 to the 5 is 10 to the 6. Okay, so I'm going to have 1 million. Okay, 10 to the power of 6 is pronounced as 1 million. Okay, 1 million has 6 zeros, guys. Okay. Question number 5. Jack calculates 6 times 10 squared plus 3 times 10 cubed equals 9 times 10 to the 5. Explain Jack's mistake and write in the correct answer. Well, when you're adding, okay, in standard form, guys, first of all, I can't just add the numbers. It has to be in the same base power for me to add, okay? If I'm adding numbers in standard form, the powers need to be the same for me to add the numbers. Because the powers are different here, I can't just add them. Okay, however, I can change this to 0.6 times 10 cubed plus 3 times 10 cubed. And now it's in like the same exponents, like the same powers of 10. I can now add my numbers, okay? Because you have to think of adding as like a place value, okay? Think of it as you convert it to like an ordinary number, and then you would add the numbers together. And if you do that, it does not give you 9 times 10 to the 5. Okay, it gives you a number that's actually much smaller than that, okay? So now it's in the same base. I can do 0.6 plus 0 plus 3, sorry, which is 3.6. 3.6 times 10 to the power of 3. Okay, I don't add my powers here. I only add the powers if I'm multiplying. If I'm dividing, I would subtract the powers or subtract the exponents. Okay, but if I'm adding or subtracting involving standard form, I need to convert it to either an ordinary number or change it so it's in like the same base power form. So it's in the same exponent form, i.e. the same power on that 10. Okay, so that's your answer in standard form, guys. But if you're interested, the ordinary number would be this number. Okay.